Hi, I'm Jenna Holman and I'm a biomedical engineering pre-major.
Hi, my name is Emily Gorowski and I'm a mechanical engineering pre-major.
Hi, I'm Mason Mooney, and I'm a pre-chemical engineer.
Hi, my name is Ethan Prohl, and I'm a mechanical engineering pre-major.
We are Group D and this is how we came about making our AEV, also known as Sparky.
Students were presented with a project at the beginning of the semester called the Advanced Energy Vehicle Project, abbreviated AEV. The main objective of this project is to complete the mission given to students. On a planet where power is a luxury, they were tasked with retrieving cargo and bringing it back while using as little energy as possible. The AEV project involves creating a monorail vehicle that can maneuver along a series of obstacles on a ceiling track in the classroom. The main goals of the project were to complete the obstacles/MCR while using as little energy as possible. This is found by using software downloaded onto the computer to analyze when and how much energy is expended throughout the run of the AEV. The AEV design process started with all 4 group members making their own individual design. And then, as a team, we came together and talked about our designs and came up with a criteria to base our final design off of. Our final design needed to be consistent, energy efficient, and cost effective. With those ideas in mind, we created screening and scoring matrices to judge our final designs. We made 2 designs and we tested both of them and collected data with both. With the data collected, we saw how efficient they were, and with cost tables, we were able to see the cost of both. We kept records of how consistent they were at stopping at the first gate, and with that information, we were able to decide our final design.
So the main goal of our design was to minimize the usage of energy and to maximize the aerodynamics of our vehicle. To do this, we incorporated the servo motor, which is able to flip the motors around into the most convenient position at any time. That way, we use the least amount of energy possible. We also made it a very thin, streamlined body to maximize aerodynamics and limit the amount of material blocking the airflow. And also we dropped the Arduino down a few centimeters just to add room to get rid of wire clutter. All this was able to maximize the aerodynamic potential of our vehicle and save a lot of energy.
The first challenge was learning to work with new team members. We had to figure out each other's strengths and weaknesses and learn how to give each other roles that fit these strengths and weaknesses. The next obstacle we faced was getting code onto the board. Originally, we noticed that we couldn't find COM4 on any of our computers. We collaborated with our TAs and found that we had a faulty Arduino, which was then switched out. After perfecting our code, we noticed that our AEV started to malfunction. After talking with our GTA Alec, we decided that the servo was faulty and we are currently in the process of fixing it. The AEV project gave students a glance into what a real-world project is like and a look into their own futures. It taught students how to better work in a team and use their project management skills to complete their own goals and meet personal project deadlines.